This is FRM Part 2, Book 1, Market Risk Measurement and Management, and the chapter on backtesting value at risk. Backtesting is a really interesting concept. It's really quite simple. Let's suppose that we're some kind of a financial risk manager or a financial analyst, and we have a model that suggests and estimates and predicts that Moody's or Standard & Poor or Fitch is going to change the rating on a well-known publicly held corporation from, let's say AAA to AA on a particular day this week. So this is what the model predicts. Then we can go and watch and see what happens, and maybe they do downgrade, maybe they don't. And then backtesting means we can see exactly what happens, and then we can go back and look at the model and see how the model was successful and how the model was unsuccessful. You guys know that I love to give sports analogies. Here's my one for this slide deck. I think this goes back to Peyton Manning when he would come off the field and immediately go sit on the bench, and somebody would hand him a series of pictures, and he would just sit there flipping through these pictures. So when he went up to the line of scrimmage, he had a model. He thought the defense was going to do something. And if the defense did what he thought, then he probably threw a touchdown pass. If the defense did something else, then he probably threw an interception. And so he was backtesting, sitting on the bench, trying to figure out what his model, whatever that model was, in evaluating and predicting the defensive alignment. So let's take a quick look at the learning objectives here. So we're going to define backtesting, take a look at some difficulties in backtesting, look at some exceptions or failure rates, and then, we've talked about type 1 and type 2 errors for lots and lots of chapters. And then we'll have to concern ourselves with unconditional and conditional coverage late in the slide deck. And then we'll go ahead and look at what happens when we have an oversight body or an organization or a government. So we'll describe those Basel rules for backtesting. If I think you live in France, that's how you pronounce it, or the Basel rules if you live in Germany or somewhere else. We'll worry about the pronunciation at some other time. So what is backtesting? Process of comparing losses predicted by a value at risk model to those, of course, that were experienced over the testing period. Now, the goal of backtesting is to ensure that the actual losses do not exceed the expected losses, right? Peyton Manning is trying to say something like, look, I want to throw more touchdown passes than I do interceptions. And what we're saying is that we've got this model that says our value at risk is going to be some number, 10 million. Well, if that 10 million value at risk was over, let's say a 2-week period, and over the next 2 weeks, we experienced losses of 50 million one day, then 80 million the next day, then 120 million. Well, something's wrong with the model. So it's really a test of the accuracy and the validity of the model. Now, of course, notice what I have in that final block point there, crucial part of model validation. And so this includes the stress testing that we've been talking about throughout these books. Let's go ahead and talk about exceptions. These are the number of actual observations over and above the expected level. I mean, if Peyton Manning goes out and throws 9 interceptions in a game, he's going to be scratching his head, and all the fans are going to be scratching their heads as well. So we need to make certain that when we say 95% of the time our value at risk, what did I say earlier, $100 million or $10 million, whatever that number is, we need to make certain that our model is valued. So look at the quick example I have here. Over 100 days, an accurate value at risk model at 95% will produce approximately, 5 exceptions, right? 95. So do the curve, do the bell-shaped curve. Look at that tail. That's going to be 5 days, right? So if there are 252 trading days in a year, That's going to give us about 13 days per year that we should reasonably expect to exceed that value at risk. Now look at these two blocks that I have on either side of that red and white exclamation point. So when too many exceptions are observed, the model has probably underestimated risk. On the other hand, when too few exceptions are observed, boy, that risk is probably overstated, and then we run the risk of having an inefficient model. I mean, we could just reasonably say, oh, our value at risk is $1 trillion and then not worry about it. But that doesn't really make sense. It's not very practical. It's not very pragmatic, and it's certainly not accurate. All right, so here are a couple of points that I've probably made here. So backtesting gives a reality check, right? Are the value at risk forecasts properly calibrated and accurate? Backtesting provides the Basel committee with a critical evaluation to test the adequacy of these internal models, right? And then it helps bank regulators to verify risk models. So the regulators come in and they say to the financial institution, they say, look, this is what you told me about value at risk, but it looks to me like it's way out here or it's way out here. I mean, it could be either. And so what is critical for bank regulators is to be able to identify when the financial institution is underestimating risk. That's the bigger problem than overestimating risk. Now, of course, actual portfolio compositions are constantly changing, on a daily basis and on an intra-daily basis. And so that value at risk estimate is going to be based on the model's output at one particular static point. And so if the composition of the portfolio changes over the next 5 days or next 10 days, let's say, significantly, well, then that value at risk estimate is probably not relevant for what's going on in the current dynamic model. Now we can go ahead and use a binomial probability distribution to determine a failure rate. And there's a good formula and equation for you to look at in the middle. T is sample size and P's are probabilities of exceptions. And so we can use that. Let's just do a quick example here. What's the probability of observing 0 exceptions out of a sample of 250 observations when the true probability is 1%? And then you can do the math there. It comes out to be 8%. Now it's interesting, if you go back and read the actual chapter, the chapter doesn't really give you an example here. It gives you the equation. It doesn't give you an example, but it does give an example of using the Z statistic. And so what we want to do here is we want to test whether a model is correctly calibrated, and we're going to have to use the Z statistic. Remember at 95%, I've told you guys this bunches of times in lots of videos, 95%, the critical value is always around 2. That's what I remembered back in my graduate school days. Of course, the actual value is 1.96. So let's work through a quick example here. 252-day trading period. Daily sales fell below a predetermined value at risk level, 95% confidence, on 20 occasions. So what did we say? A couple slides ago? That how far back? So that should be 95%. That's about 13 days a year. So this example, what does this one tell us? On 20 occasions. So is the model correctly calibrated? All right. So the null hypothesis is that the model is unbiased. We can put together that Z statistic from the formula right there. So we get 2.14. And so that's going to be to the left of our, to the right of our 1.96. Therefore, we reject the null hypothesis that the value at risk is unbiased, and because the maximum number of exceptions has been exceeded. Now, remember right there, we did that two-tailed test, and don't confuse that with the value at risk confidence with it, which is just a one-tailed test. Remember, in the value at risk, we're just throwing everything in the left tail. But for a Z test and a T test, in this case, we're going to have a two-tailed test. How about type 1 and type 2 errors? The easiest way to remember the difference between these two guys is to remember that a type 1 error is an error of commission, and a type 2 error is an error of omission. So I always remember this back in my investment days, and I wonder if you guys do as well, is that if you are a financial institution hiring a portfolio manager, what's the goal? To hire the best portfolio manager. So you set up the null hypothesis that a specific candidate stinks, right? A specific candidate is going to underperform. So you want to bring in candidates so that you can reject that null hypothesis. And so a type 1 error is that you say something like, okay, this candidate stinks, but the interview goes so well that you hire the candidate, and in fact, the candidate does in fact stink and does underperform. So a probability of rejecting a correct model. Of course, there are lots and lots of behavioral issues that come into play when you make a type 1 error, which is different than a type 2 error. This is when you fail to hire a portfolio manager who is superior. And so probably the big takeaway there is the definition of those two. And just remember that type 1 error is represented by alpha, and type 2 is represented by beta. Now, at this point, we've looked at backtesting based on unconditional coverage, in which the timing of those exceptions has not been considered. And so what did we come up with that last example, that Z test? We had, 20 exceptions, and that was spread out over an entire year. But here's the deal. Suppose that those 20 exceptions occurred on 20 consecutive days. At some point, you might think, maybe after day 2 or 3, you might think, I wonder if yesterday's stuff is affecting what's going on today. All right, so the unconditional variation falls in line with the independence assumption, right? But in reality, there could be some time variation in the way those exceptions are observed and the time series in which they occur. So conditional coverage allows us to take into account those factors that the unconditional coverage ignores. Maybe there are just crashing markets all over the place. So look what I have in the first circle point there in the middle of the page. Actual exceptions could cluster or bunch closely in time, such that if we take the value at risk at 95%, those 13 exceptions might occur together or within a single month. Now, those can be random, or they can be due to correlations or some other link. And so notice what I have in the last arrow point. Further tests to establish if the clustering is random or if it's caused by correlation. All right, so the committee has put in place a framework based on daily back testing of value at risk. And so this is kind of interesting. Here in the United States, when we drive around, we have green lights and yellow lights and red lights. And I'm guessing that's similar driving rules throughout the world. But here we go, like the green light and the yellow light and the red light. So it's interesting to look at this table because green light is definitely green, right? That means that the financial institution can probably continue to use its existing model. The red light is a suggestion that the financial institution probably should not continue to use its existing model. So green and red, those are signals that either the model is probably working well or the model probably is not working well at all. The interesting part falls in the middle with the yellow light. And of course, when you're driving and that yellow light hits you and you're thinking, all right, do I have enough time to get through? So you have to go through the whole process of, is there a policeman or a policewoman by to see if I'm going to actually run a red light, et cetera, et cetera. All right, so note in that middle column the number of exceptions. So if you go from 0 to 4, that's a green light. 10 or more is a red light. And then 5 to 9, boy, there's a wide range to try to figure out whether or not we're going to attract a penalty, or if we need to continue using the model, make some adjustments, make some small adjustments, make some large adjustments. Remember, the goal is to put together a value at risk model so that we don't underestimate or overestimate risk. Now, the committee uses 4 categories to try to figure out what's going on in that yellow zone. So we'll go through these 4 models. So let's look at the basic integrity of the model. Are the bank systems poor at capturing the risks of various positions taken? Of course, this could be because correlations have been misspecified, or there could be some other reason as well. All right, the guidance here is this is a serious flaw, and so immediate corrective action is necessary. How about a deficient model accuracy? This implies that the model does not measure the risk exposure with enough precision. Remember, this is why we do these confidence intervals, right? Do we want this much confidence? You can't completely eliminate risk. Do we want this much? Do we want this much? Or are we satisfied with this much? So if we don't have enough precision, the guidance is that, this is a pretty common flaw. Boy, we'd love to be able to identify a really narrow range for value at risk. But we also know that the dynamic nature of capital markets and risk management strategies are dynamic, right? So as such, no model is going to be fully immune to some kind of variability or a lack of precision. There's also this interesting concept about intraday trading. Let's suppose that these exceptions occur within just a 24-hour or a 12-hour period. And if that exception were to go away, that's not because of the model, it's because of something else. And then here's my favorite one, bad luck. You guys know I like to give James Bond examples. Do you remember in Goldfinger, when Goldfinger hit his ball into the rough and James Bond said, "Oh, bad luck, you're in the rough." So this is really kind of what the committee is saying. We need to make certain that bad luck is not repeated. That's really the idea. Of course, no model is immune from bad luck. No model is immune from all of the economic catastrophes that can occur. Maybe it's this, kind of a swirling together of all these factors that just coincided with our particular financial institution on one day. And I think that takes us through all of these learning objectives.